In the last video, we created this platform physics custom block that allows us to run and jump in a Scratch game like you would see in a platformer like maybe Mario. Now, this is really useful, but one question that I see a lot of people have is how to animate the player. So you can see I've got this Scratch Cat player here, and whether I go right or left, whether I'm running or jumping, he always looks the same. And ideally, we could sort of animate this guy to run and jump in ways that look a little better. So I've got a couple of extra costumes here, and I want to try to animate it. Now, the first thing that we might try is to say, all right, whenever certain things happen, we're going to change the costume. So for instance, when we land on the ground, which happens here with the if touching ground block right at the beginning, we could say, all right, when that happens, switch to Cat 1A, which is sort of this standard standing on the ground kind of sprite. So we could say, switch to that costume when we're touching the ground. Then we could also say, okay, maybe when you jump, I want you to have this flying animation. So maybe we say, if your y velocity is greater than 0, I'm just going to steal that from here, and if your y velocity is greater than 0, then switch to the flying sprite. And the idea here is that if you are moving up, if your vertical speed is positive, if you're going in the positive direction, then you'll be in this flying costume, or in this case, this would sort of be jumping. And we could just throw this really anywhere in our script. I'll put it right before the arrow keys. And then we could also say, let's do some direction changing. So if you turn right or left, we can change that as well. So we turn our rotation style to right-left, which means that if we do a point in direction, it won't actually turn all the way around. It'll just flip back and forth. And we can say, okay, when you press the right arrow, point to the right. And when you press the when you press the left arrow, point to the left. And if we do all this, it will kind of work. You can see, but we get stuck in the wall, and the physics start breaking. So you can see it does work that when you jump, you switch to the flying sprite, and when you turn left and right, you move to the left and the right. But it's very easy now for the physics to be broken. And the first question is, why? Why does switching costumes break the physics to do bizarre things like this? And the answer is that we're using the touching block a lot throughout the script. So we say, if you're touching the ground, that's how we know we need to move the player in some way and affect their speed. And the problem is that by changing the costume of the sprite, we're actually changing exactly how that touching block works. So when you're in the Cat 1A sprite here, it's going to use this sprite as collision detection. It's going to use this to determine whether or not you're inside the wall. But then when you switch to the flying sprite, this has a slightly different set of boundaries. So maybe you're on the flying sprite, and you have a wall right here where this rectangle is. And right here, the flying sprite is okay. It's not inside the wall. But then as soon as it lands, you might switch to this sprite, where the wall is in the same place, but now suddenly the cat is inside the wall. And in this way, you can sort of break the physics. Changing the costumes affects the way that the touching blocks work. So what we really want is to be able to change these costumes and change the direction that we're pointing without it affecting the actual physics. So we're going to do something kind of cool here, where rather than actually switching the costume and actually pointing in certain directions right away, we're going to tell the script, wait and do that later. First, just do the motion using a regular sprite in a regular direction, and then at the end, once all the physics are taken care of and we're not worried anymore about what the touching block has to say, after all that happens, then we can switch to the actual costume and the actual direction that we want things to show up as. So what I'm going to do is I'm going to start my script by saying, always, before you do the physics, switch to the standard sprite. Right? Switch to the kind of the most normal sprite, and we're going to use this sprite for collision detection. We're going to use this sprite whenever the touching block is running. So whenever there's a touching block, this is the sprite that's being used. We're also going to say point in the direction 90 or to the right, and this will give us a standard direction. So now all of the touching blocks in the script, once we fix our switch costume to and our point in direction, all of these will use the same costume and the same direction all the time. So our physics will be back to working. But in order for that to be the case, we have to get rid of the switch costume and the point and direction blocks inside of our script. Well, that seems like it's going to defeat the purpose, right? The whole thing that we want to do is switch costume and point and direction. But what we can do is delay it and only switch once the script is over. So everywhere that we have a switch costume to, I'm going to replace it and use a variable instead. Now, I'm going to mark this variable as for this sprite only, so that, other sprites like the ground don't have to deal with it. And then I'm just going to say, okay, instead of saying switch costume to cat1a right now, I'm going to delay that until later. So what I want to do is store in this costume variable some information about which sprite we should switch to once all of the physics are over. And the way that I'm going to do that is by using costume numbers. So you can see in the top left here, this cat1a is number 1, cat1b is number 2, cat flying is number 3. So what I want is number 1. So rather than actually switching the costume, I'm just going to tell this variable to store the number 1 and say, hey, later on, we'll use that number to switch to the right costume. So I can get rid of this now. Again, right here, I'm saying if the y velocity is greater than 0, if you're moving up, then we're going to switch to the flying sprite. Now that's great, but I don't want to do it right away. I want to do it later. I'm going to delay the costume change. So this is sprite number 3. And so I'm just going to add a variable, or add this set variable 2. So I'm going to set the costume to 3. And again, doing this won't actually change the costume, but it'll allow us to do it later. So now that I've replaced those blocks, at the very end of our script, after everything has been taken care of, after all the touching blocks have been used, and we're no longer concerned about how the costume will interact with those touching blocks, then at the very end, we're going to use that costume variable to switch to the actual costume that we want. And if you didn't know this, you can actually plug variables right in to this drop-down menu, and as long as this variable is a number, it will switch to that costume number that you specified. So just by setting the number here, it allows us to store which costume we want, and then down here, we can actually switch to it after the physics are done. And because this block is running without screen refresh, it means that all of these things, all of the costume switching at the beginning and the end, cannot be seen by the user. It won't be visible. It'll just affect how Scratch works internally. So that's really good, because now it looks essentially the same, but our cat no longer has this problem with the physics, almost. Except our direction, you can see, is still broken. So our direction, we're going to use basically the same solution as we did before, where down here in the right and left arrows, we were saying immediately point in that direction. And instead what we want to do is say, well, hang on, don't point in that direction yet, because it's going to affect our physics. Instead, we'll make a variable, which I'll call direction. And again, I'll make it for this sprite only. And I'm going to say, rather than pointing in that direction right away, let's just point in that direction after all of the physics have been taken care of, because we want this to be a visual thing only. So we'll use this variable to store which direction we want the player to go in. And at the end of the script, we'll say, okay, now point in that direction for real. Point in direction based on this variable that we've saved. So hopefully, this should do the trick. Now I can move left and right and do the jump without it breaking the physics. You can see where I used to be getting caught in the floor and in the ceiling and having all sorts of problems. That's not the case anymore. Everything works exactly how we would expect it to. So this is really good. This is essentially a solution. The only little thing that I want to change is that at the very beginning, when we click the green flag, we should probably reset these variables to something reasonable. So I'm going to say, when we start, set the costume to number 1, which is just the standard costume, and set the direction to 90, which is to the right. And that way, our script will know exactly what to do the first time that it runs. And I just accidentally added a comment here. That was not super clever. But now it'll know what to do right off the bat. And so this is totally working. And if this is all that you want, then great. You've got a solution here, and you're good to go. But one thing that I think might be cool would be to have a running animation. So you can see as I'm moving to the left and to the right, the guy turns to the left and to the right, but his feet don't move. They just sort of glide along the floor in a hovering kind of manner, which is cool, but not very realistic. So if we wanted to change that, and we wanted to alternate back and forth, how would we do that? It's actually a little complicated, unfortunately, but basically what we want to do is say, hey, rather than, when you're on the ground, always switching to costume number 1, we want to do kind of an alternating deal, where sometimes when you're on the ground it switches to costume 1, but sometimes it switches to costume number 2. So I'm going to have an if-else block that says, basically, sometimes switch to costume number 1, and other times switch to costume number 2. And if we do that in an alternating way, if we can make this if-else block alternate what it chooses, then we'll be able to make that nice running animation. But how are we going to get that alternation? This is where it gets a little bit tricky. I'm going to use the timer as a way of keeping track of where we're at in the animation. The timer can sort of time our animation. And I want it to be a half-second cycle. So basically, every half second, it'll go through the entire animation cycle. And then basically every quarter second, it'll switch costumes. So it'll be a quarter second on Cat 1A, a quarter second on Cat 1B, quarter second on A, quarter second on B. Back and forth, spending a quarter of a second on each one until we stop moving. So the way that I'm going to do this is a little bit tricky. It's using the mod block. And I'm just going to do the timer mod a half. This stands for modulus. And basically, this operator does division and then gives us the remainder. So let's say that I had 7 mod 3. Well, if you do 7 divided by 3, that gives us 2 with a remainder of 1, because 3 times 2 is 6, and then there's 1 left over to get to 7. So you can see 7 mod 3 is 1. Now, you can also do it with like a half, like with a fraction. So if we said, 1.75 mod a half, this is going to give us 0.25, because the division would be 3 with a remainder of 0.25. And again, this is a little tricky to wrap your head around, but essentially what this means is that timer mod 3 will be constantly counting up, just like the timer is constantly counting up. But then every half second, the value will jump back down to 0. So it'll just be counting in half-second increments. So it'll go 0, and then 0.1, 0.2, 0.3, 0.4, 0.5. And actually, at 0.5, it'll jump back down to 0. So this value will just be going up to 0.5, back, and then jump back down to 0. And what this is useful for is comparing to 0.25. Now, 0.25 is half of 0.5, right? So this is really a half, and this is a quarter. And the idea is that half of the time, this counting up to a half will be less than a quarter, and then the other half of the time, it'll be greater than a quarter. And so every quarter of a second, this will alternate between true and false. So if I put this in here, now you can see every quarter second, the cat is alternating between costume number 1 and costume number 2. Our if-else is going between choosing the first one and choosing the second one. Now, the only problem here is that it does it even when we're not moving. So I'm going to add one more condition. I'm going to say I always want it to be costume number 1 if you're not moving very quickly. If you're not moving at all, or you're just moving a little tiny bit. So I'm going to add an or block in here, so that if our timer happens to be at the certain part of the animation where we choose costume 1, then of course choose costume 1. Or if we're not moving very quickly, also choose costume 1. And the way that I'm going to do this is by saying if the absolute value of the x velocity, ABS stands for absolute value, if the absolute value of the x velocity is less than maybe 2, then it's going to always choose costume number 1 by putting this in the OR block. Now, let's take a quick look to unpack what this means. Absolute value will make a number always be positive. So if we take the absolute value of -3, it'll give us positive 3, regular 3. If I take the absolute value of -7, it'll give us 7. But if I plug in a number that's already positive, it'll give us the same positive answer. So the absolute value of 8 is just 8. So by taking the absolute value of the x velocity, basically what we're saying is, I don't care if you're moving to the right or to the left. I don't care about the direction. All I care about is the speed of the movement. And if the speed is less than 2 pixels per frame, then you're not moving very quickly, and so I'm going to want you to be in the standing costume, not the running one. So I put that inside the OR block, and now we've got kind of a big expression here, but it does exactly what we want. If we're not moving, like right now, then we just always choose costume 1 because our speed is less than 2. But if we are moving at a speed greater than 2, you can see that the cat animates, and every quarter second it changes costume. But it still works when we jump. It has the flying costume. So this is a much more complicated solution. You can see there's a lot going on here, but it does work, and your physics will continue to function as well.